Hello dear students, in this lesson we are going to learn more about features that was added in Java version 9. I am talking about modules in Java. Today we have really a lot of new things to learn. Modules really powerful features that exist in Java platform, and if you want to become Java software engineer or get one of Oracle certifications, you have to be familiar with it. We'll start lesson from simple and general topics such as what modules are, and just talking about why we might need them. To help you understand modules better, I will explain what goals we are trying to achieve by using them and what benefits we expect to get. We'll review different module types. After that, we'll learn module directives that we use in module descriptor and command line options that might come in handy when you will work with multiple modules from console. And at the end of the lesson, we are going to create modular Hello World application, and I will show you how to configure Eclipse in order you can work with modular application from Eclipse. As you can see, we have really a lot of things to do. Let's start our lesson. Let's understand first what modules are. Module is a uniquely named, reusable group of related packages as well as resources, such as images and XML files, and module descriptor specifying the module's name, the module's dependencies, that is other modules this module depends on, the packages it explicitly makes available to other modules. All other packages in the module are implicitly unavailable to other modules. The services it offers, the services it consumes, to what other modules it allows reflection. A Java module is a packaging mechanism that enables you to package a Java application or Java API as a separate Java module. A Java module is packaged as modular jar file. A Java module can specify which of Java packages it contains that should be visible to other Java modules which uses this module. A Java module must also specify which other Java modules are required to do its job. In more simple words, Java module is a package for packages. That is super simplified, but hope this will help you to understand this concept. You can group packages into modules, and to ensure encapsulation, you may control access to different packages within the module. Modularity adds high level of aggregation above packages. Is it clear? Java Modules is a new feature in Java 9 via the Java Platform Module System. The Java Platform Module System is also sometimes referred to as Java Jigsaw or Project Jigsaw, depending on where you read. Jigsaw was internally used project name during development. Later, Jigsaw changed name to Java Platform Module System. There is a JSR 376. JSR stands for Java Specification Request. This is an actual description of proposed and final specification for the Java platform. At any one time, there are numerous JSRs moving through the review and approval process. In the JSR 376, we can find list of goals of modularizing the Java SE platform. Among them, such goals as reliable configuration. Modularity provides mechanisms for explicitly declaring dependencies between modules in a manner that's recognized both at compile time and execution time. The system can walk through these dependencies to determine the subset of all modules required to support your app. From Java 9 and forward, Java applications must be packaged as Java modules too. Therefore, an application module specifies what other modules, Java API modules or third-party modules, it uses. Therefore, the Java virtual machine can check the whole module dependency graph from the application module and forward when the Java virtual machine starts up. If any required modules are not found at startup, the Java virtual machine reports the missing module and shuts down. Before Java 9, missing classes, from a missing jar file, for example, would not be detected until the application actually tried to use the missing class. This would happen sometime at runtime, depending on when the application tried to use the missing class. Having missing modules reported at application startup time is a big advantage compared to at runtime when trying to use the missing module jar class. Strong encapsulation. The packages in a module are accessible to other modules only if the module explicitly exports them. Even then, another module can't use those packages unless it explicitly states that it requires the other module's capabilities. This improves platform security because fewer classes are accessible to potential attackers. You may find that considering modularity helps you come up with cleaner, more logical designs. Scalable Java platform. Previously, the Java platform was a monolith consisting of a massive number of packages, making it challenging to develop, maintain, and evolve. It couldn't be easily subsetted. The platform is now modularized into 95 modules. This number might change as Java evolves. You can create custom runtimes consisting of only modules you need for your apps or the devices you are targeting. For example, if a device does not support graphic user interfaces, you could create a runtime that doesn't include the GUI modules, significantly reducing the runtime size. Before Java 9 and the Java Platform module system, you would have had to package all of the Java Platform APIs with your Java application, because there was no official way of reliably checking what classes your Java application used. Since the Java Platform APIs have grown quite large over the years, your application would get a large amount of Java classes included in its distribution, many of which your application would probably not be using. Greater platform integrity. Before Java 9, it was possible to use many classes in the platform that were not meant for use by an app's classes. With strong encapsulation, these internal APIs are truly encapsulated and hidden from apps using the platform. This can make migrating legacy code to modularized Java 9 problematic if your code depends on internal APIs. The unused classes make your application distributable bigger than it needs to be. This can be a problem on small devices like mobile phones, Raspberry Pis, etc. With the Java Platform module system, you can now package your application with only the modules of the Java Platform APIs that your application is actually using. This will result in smaller application distributables. Improved performance. The JVM uses various optimization techniques to improve application performance. GSR 376 indicates that these techniques are more effective when it's known in advance that required types are located only in specific modules. And this was a great improvement for Java as a platform. Nowadays, questions about modules are among main questions during different Oracle certifications. Let's talk now about different modules types. There are 4 types of modules in the new module system. System modules. These are the modules listed when we run Java list modules command. They include the Java SE and JDK modules. Application modules. These modules are what we usually wanna build when we decide to use modules. They are named and defined in the compiled module-info class file included in the assembled jar. Today we are going to create with you our own module-info file and see all examples. Automatic modules. We can include unofficial modules by adding existing jar files to the module path. The name of the module will be derived from the name of the jar. Automatic modules will have full read access to every other module loaded by the path. Unnamed module. When a class or jar is loaded into the class path but not the module path, it's automatically added to the unnamed module. It's a catch-all module to maintain backward compatibility with previously written Java code. The unnamed module concept is similar to the default package. Therefore, it is not considered a real module, but can be viewed as a default module. We can create multi-module projects comprised of a main application and several library modules. We have to be careful though, because we can only have one module per jar file. Let's learn now what module descriptor is and what are different directives that may be used in module-info.java file. As we have discussed already, a module must provide a module descriptor, metadata that specifies the module's dependencies, the packages the module makes available to other modules, and more. A module descriptor is a compiled version of module declaration that's defined in a file named module-info.java. And the first thing that we need to do is to create a file with name module-info and with Java extension. This file should be located in the source root directory. Each module declaration begins with the keyword module, followed by a unique module name and the module body enclosed in braces, like you see in our example. A Java module name follows the same naming rules as Java packages. However, you should not use underscores in module names, or package names, class names, method names, variable names, etc. from Java 9 and forward, because Java wants to use underscore as reserved identifier in the future. It is recommended to name a Java module the same as the name of the root Java package contained in the module, if that is possible, because some modules might contain multiple root packages. The module declarations body can be empty or may contain various module directives, including requires, exports, provides with, etc. We are going to discuss each of these in a few minutes. As you'll see later, compiling the module declaration creates the module descriptor, which is stored in a file named module-info class in the module's root folder. On this slide, I will briefly introduce each module directive. They are keywords only in module declarations and may be used as identifiers anywhere else in your code. Let's learn now directives. The first directive that we are going to learn is requires. This module directive allows us to declare module dependencies. For example, in this case, my module has both a runtime and a compile time dependency on some module that you should refer by module name. Each module must explicitly state its dependencies. When module A requires module B, module A is set to read module B, and module B is read by module A. To specify dependency on another module, use requires. And all public types exported from a dependency are accessible by our module when we use this directive. Another important mention here is that it is not allowed to have circular dependencies between modules. In other words, if module A requires module B, then module B can't also require module A. The module dependency graph must be an acyclic graph. Another directive is require static. We might write a utility function that pretty prints our internal state when another login module is present. But not every consumer of our library will want this functionality, and they don't wanna include an extra login library. In this case, we wanna use an optional dependency. By using the require static directive, we create a compile time only dependency. Now, let's learn transitive directive. Imagine that we want to use third-party library and that library in turn has other dependencies. How we can make sure that any module that we are dependent on will bring its own dependencies to work properly? We can force any downstream consumers also to read our required dependencies with requires transitive directive. Let's review exports directive now. As you already could understand that strong encapsulation was one of the main goals when Java Platform Module System has been introduced. By default, a module doesn't expose any of its API to other modules. Our code is significantly more secure if we don't expose our API to external users. But what if we created API that should be used by different modules and we need to explicitly make it available for everyone? We use the exports directive to expose all public members of the named package. Please note that only the listed package itself is exported. No sub-packages of the exported package are exported. That means that if this package in my example contains a sub-package named util, then the comp my package name util package is not exported just because of parent package is. To export a sub-package also, we must declare it explicitly in the module descriptor. And one more rule. The same Java package can only be exported by a single Java module at runtime. In other words, you can't have two or more modules that export the same package in use at the same time. The Java virtual machine will complain at startup if you do. Having two modules export the same package is also sometimes referred to as a split package. By split package is meant that the total content classes of the package is split between multiple modules. This is not allowed. In case we want to limit access to our API and expose it only to some packages, then we have to use exports to directive. Similar to the exports directive, we declare a package as exported. But we also list which modules we are allowing to import this package as it requires. And here is how it looks like. The next directive is uses. A uses module directive specifies a service used by this module, making the module a service consumer. A service is an object of a class that implements the interface or extends the abstract class specified in the uses directive. We designate the services our module consumes with the uses directive. Note that the class name we use is either the interface or abstract class of the service, not the implementation class. Because service in this context means an implementation of a specific interface or abstract class that can be consumed by other classes. But what is the difference then between uses and requires directives? We might require a module that provides a service we want to consume, but that service implements an interface from one of its transitive dependencies. Instead of forcing our module to require all transitive dependencies, just in case, we use the uses directive to add the required interface to the module path. Is that clear? We have discussed directives that consume the services. But this also means that we have modules that provide services. So, a module can also be a service provider that other modules can consume, and we can ensure this with provides with directive. We should write provides keyword first and specify the interface or abstract class name of our service. The next thing what we have to do is to specify what specific implementation of our service we are going to provide. With the help of with directive, we provide the implementation class name that either implements the interface or extends the abstract class. The next important declarations that I'd like to show you are opens and opens to. Let's learn these. Before Java 9, reflection could be used to learn about all types in a package and all members of a type, even its private members, whether you wanted to allow this capability or not. Thus, nothing was truly encapsulated. Like we have discussed already, the key motivation of the module system is strong encapsulation. By default, a type in a module is not accessible to other modules unless it's a public type and you export its package. You expose only the packages you wanna expose. With Java 9, this also applies to reflection. For example, we can allow runtime-only access to a package. So directive open_some_package indicates that a specific package's public types and their nested public and protected types are accessible to code in other modules at runtime only. Also, all the types in the specified package and all of the type's members are accessible via reflection. Another example, we can allow runtime-only access to a package by specific modules. An opens_to_module directive, like for example, opens package name to some listed modules, indicates that a specific package's public types and their nested public and protected types are accessible to code in the listed modules at runtime only. All of the types in the specified package and all of the type's members are accessible via reflection to code in the specified modules. We have discussed already that one of the main goals of modules is strong encapsulation. And I believe that you watched the previous lesson and you're pretty familiar with reflection by this moment already. So you can understand that before Java 9, it was possible to use reflection to examine every type and member in a package, even the private ones. Nothing was truly encapsulated, which can open up all kinds of problems for developers of the libraries. Because Java 9 enforces strong encapsulation, we have to explicitly grant permission for other modules to reflect on our classes. If we want to continue to allow full reflection as older versions of Java did, we can simply open the entire module by using open directive before module name, like you see on the slide. Does it make sense so far? And please always remember that in case you have any questions, please post them below this video and I will be happy to answer those. We have just learned directives that we can use in our modules-info file. The next step would be to learn how to build our modules. And before I show you examples of how to do that, let me explain different command line options that we can use when we build Java modules. Even despite the fact that later in our course we are going to learn such build tools as Gradle and Maven, and they already have support for building modules in Java, it's still valuable to know how to use module system from the command line. We will be using the command line for our full example that I'm going to show you in a few minutes to help solidify how the entire system works in our minds. Module path. We use the module path option to specify the module path. This is a list of one or more directories that contain our modules. Add reads. Instead of relying on the module declaration file, we can use the command line equivalent of the requires directive. Add exports. Command line replacement for the exports directive. Add opens. Replace the open clause in the module declaration file. Add modules. Adds the list of modules into the default set of modules. List modules. Prints a list of all modules and their version strings. Patch module. Add or override classes in modules. Illegal access, with values either permit or warn or deny. Either relax strong encapsulation by showing a single global warning, shows every warning, or fails with errors. The default is permit. Finally, we are done with the minimum theory piece. Let's continue learning modules with examples now. This would be our Hello World modular application. Thus, it wouldn't be super complicated, because the main goal right now is to make you understand key principles of modular application. The rest of the things will be super easy to understand if you learned how everything works under the hood. So, first of all, I wanna say that for the sake of the demo, I created separate multi-module project. I will share with you link to it in attachments to this lesson. I have root project folder, and I created modules folder. Apparently, this folder will contain different modules of my app. It is rule of thumb to name modules as the root source package. For example, if the top level package of the module is com itbools greetings, then I name the module in the same way. Notice the full stops in the module root directory name. These full stops need to be there because they are part of the module name. They are not to be interpreted as subdirectory path dividers. Is it clear? As you can see, I have two modules here. Let me start from greetings one. It contains class with name greetings and static method inside that prints hello world to console. Each module should have module-info file. Let's look at the module descriptor of this module. On the top you can see module name. Basically module name and name of the module folder should match. And we export package from this module. Exports directive is used with package name. Let's now create the second module. The name of my second module is itbools app. This is the main module that uses greetings module. It has only one class with main method, where we use greetings class to invoke say hello method. Pay attention that we also have import statement here to import greetings class from another package. This module also has module descriptor. Let's look at it. Here we can see that this module requires my greetings module, and this is obvious, agree? Because we are using class from greetings module in this one. Do you understand dependencies between these two modules? If yes, then great. If no, please press pause for a minute and think about it one more time. The next step that we need to do is to compile our modules. Especially for that, I created a script that will compile all sources. It is located in the root directory and it is called build.sh. I use Linux shell commands here, so pay attention you run this script either on Linux platforms or from git bash on your Windows machine. And do not use Windows command line to run this script. You know what Javac means? This is our Java compiler. After that I pass name of the output directory to specify where I wanna put compiled classes. The next thing I do, I need to pass module source path option. This is different from the one I shared before. If you remember, we reviewed what module path is on a separate slide. There is a difference between module path and module source path. The compiler needs a distinction between the code it needs to compile in module source path and location of compiled dependencies and libraries, module path. Does it make more sense now? I pass here name of my folder with modules. After that I use shell command to find all files with Java extension in modules folder. Once my modular app is compiled, I can run it. I have another script for this that is called runapp.sh. Let's look at it. In this script you also see program that is familiar to you, Java. I wanna start Java virtual machine. I use option module path to pass the reference to the compiled modules. And after compilation, all of them are stored in target output directory. You can see that all files here have class extension, and even module-info file is compiled into class file. Then I specify the path to the class that contains main method. The path consists of module name and full class name. So, in this particular example, com-it-bulls app is the module name and com-it-bulls app is the full class name. Is this clear? For the sake of the demo, I opened git bash inside Eclipse. I run build.sh script first, and after that I run app script. And here in console we can see hello world from Modular application. Can you see this? Congratulations to you with your first Modular application. One more small comment here. By the moment of recording this video, there is no single and proper way of using Eclipse to run multi-module application. There might be some additional steps to configure multi-module application in Eclipse. That's why, even on your work, most likely you would use command line to build and to run your complex enterprise application. For the sake of convenience, you still can work in Eclipse, but you need to be prepared that sometimes you would see more errors than usual, because sometimes it is either hard to configure all dependencies not in the app, but in Eclipse itself, in order Eclipse would understand clearly dependencies between all modules. Here is an example. You can import two modules as separate projects and work in Java editor with Java files. But in app module, you may see error because Eclipse can't see dependency on another module, since technically, for Eclipse, this is a separate project, and Eclipse allows only one module-info file per project. In order to remove the error, sometimes you may need to configure dependencies manually if Eclipse didn't manage to configure everything automatically. For example, in my app module, I open Build Path submenu, Configure Build Path, and here on Libraries tab, under Module Path, I select Add Class folder. Here I put checkbox next to the module that I need in this one, namely Greetings module, and press OK. Now you wouldn't see any errors in Eclipse. But in case you have multiple modules and not all of them are configured automatically, this may take time during the configuration of your project very first time. After these configuration steps, you may run app even from Eclipse. Can you see this? Great! Since you have learned these simple things already, let me show you how to add a service to our modular application. In my Greetings module, I declare an interface with name Service Status Logger that contains only one method, print service status log. I have implementation of this interface that is called Default Service Status Logger. For the sake of our demo, it just prints text to console. Now, in my module-info file, I need to declare that this module provides such service with the concrete implementation. I use provides with directive for this. The next logical step would be to consume this service in my app module. I use uses directive for that and specify full class name of the interface. After that, in app class, with the help of service loader from Java util package, I can load my service. I use load method and pass the class of the service that I need. Service loader is iterable type. That's why it has iterator method that allows me to get the reference to the first service loader object in the sequence. Having the reference to the object, I can call print service status log method. Let's now use our git bash to compile new sources one more time and run our app. In console you can see that we successfully managed to invoke service method. That's all what I wanted to share with you in this lesson. Let's recap what we have learned in this lesson. In the lesson we have learned what Java modules are. Also you know the goals that we wanna achieve and that are captured in GSR 376. We have learned different modules types. After that, we reviewed in details different command line options to work with modules. And on real example, you saw how to create, build, and run modular application. Together we configured Eclipse to work with modular application from IDE. And at the end of the lesson I explained you how to provide and consume service in different modules. Thanks a lot for your attention. Have a great day and see you in the next lesson.